Okay, last night we looked at Theorem 24, which was the first of the two equidistance theorems. And you'll recall we started out looking at a figure like this. In fact, this is a copy of it. And we were told that the segments connecting point P to the endpoints A and B were congruent, and the segments connecting point Q to the endpoints A and B were congruent. And if that were true, we walked through a proof showing that PQ, the blue line, was the perpendicular bisector of the red line. Well, Theorem 25 is the converse of Theorem 24, and it also bears our attention. So let's look at another set of givens. I guess it's worth taking a minute to notice it is the opposite of last night's givens, so it's not surprising that we're proving the converse of the theorem. So instead of being given that segments are congruent, that's what we're proving. And instead of proving perpendicular bisector, we are given that PQ is the perpendicular bisector of AB. So, since PQ is a perpendicular bisector, I know that angle AMP and angle BMP are right angles, because if two segments are perpendicular, they meet at right angles. And since PQ is a bisector, I know that AM is congruent to MB. And then by the reflexive property, PM is congruent to itself. So, by side angle side, I can conclude that triangle AMP is congruent to triangle BMP. And so, by CP/CTC, AP is congruent to BP. Now, if we wanted to prove the other conclusion, that AQ was congruent to BQ, we would do that by a very similar proof, only we would be working with the two triangles down at the bottom. Okay, so that means that if we are given something's a perpendicular bisector, it's not very hard to prove that any point on the perpendicular bisector is equidistant from the endpoints of the segment. In other words, a segment stretching from a point to either endpoint will be congruent. And that's what Theorem 25 says. If a point is on the perpendicular bisector, the blue line, then it is equidistant from the endpoints of the bisected segment. So it doesn't matter whether I make a point here, point D, point E, point F, or even if I extended PQ way down here and put a point G, I could be sure that GA would be congruent, I could be sure that GA would be congruent to GB so long as I was sure that it was on the perpendicular bisector. Okay, that's Theorem 25. So the two theorems are very, very handy. Let's take a minute to look at a chart that shows us how we know when to use which theorem, because the proofs might get a little bit confusing. Okay, so our given information is that we have congruent segments, and we're trying to prove perpendicular bisector, or we see perpendicular in the what we have to prove, or we see bisector in what we have to prove. The theorem we're going to use is Theorem 24. On the other hand, if we're given or we see perpendicular bisector and we have to prove congruent segments, then you're going to want to use Theorem 25. Now sometimes, as we'll see in an example, we're given congruent segments and we have to prove congruent segments, in which case you're going to end up using both Theorem 24 and Theorem 25. I'll upload this chart so that you can download it into your notes. Okay, I'm going to show you a couple of examples of proofs that come up in this section, and I hope this all helps. Thanks. Okay, here we're given that AB, BC, CD, and AD are all congruent, and they want us to prove a perpendicular bisector. So if we take a look at that chart, that's clearly an example of the first line of the chart, where we're given congruent segments and we have to prove perpendicular bisector. So we should be aware that we're probably going to be using Theorem 24. That was the first of the theorems we learned. Okay, so how are we going to prove it? Well, let's take a look at the proof. The equidistance theorems are really powerful. So once we establish that we have two equidistant points, that is to say, once I show that A is equidistant, is as far from B as it is from D, and C is as far from B as it is from D, then I have 2 points equidistant from the endpoints of a segment. Therefore, those 2 points determine the perpendicular bisector. So it's not much of a proof once you learn these two theorems. Now let's take a look at an example of using the converse. Okay, in this next example, here we see perpendicular bisector in the givens, but we're not proving congruency, we're proving congruent angles. Well, hopefully we remember enough from section 3.7 to recognize that if we have to prove angle 1 congruent to angle 2, then maybe all we need to do is show that BD is congruent to DC. So let's work through the proof. Alright, since I know AE is the perpendicular bisector of BC, then I know point D has to be equidistant from point B and point C. So DB is congruent to DC, because if a point is on the perpendicular bisector, then it's equidistant from the endpoints of the segment. So if I know BD and DC are congruent, then if sides, then angles. So angle 1 is congruent to angle 2. Short and sweet. All right, let's take a look at one more example. Okay, in this last example we're going to look at, I don't see any perpendicular bisector and I don't see any congruent segments. But let's take a closer look. If we see that angle EAC is congruent to angle EBC, then it won't be hard for me to prove that EA and EB are congruent. And if I know that DAC, this big angle, is congruent to DBC, the big angle, then it wouldn't be hard for me to show that DB is congruent to DA. So there I have it. I have 2 points, D and E, which are equidistant from the endpoints of a segment. And we can color that. So there's that red segment, and just as in our first example, there's our blue segment. So I can prove perpendicular bisector. And so any point on that perpendicular bisector, on that blue line, is going to be equidistant from A and B. Well, point F is on that perpendicular bisector, so it won't be hard for me to show that FA is congruent to FB. And then, if sides and angles, I can show that angle FAC is congruent to FBC. Let's take a look at the proof. As you can see, it's all laid out there. But notice, going back to our chart, if we're given congruent segments and we have to prove congruent segments, we're going to use both theorems. Okay, we weren't really given congruent segments, we were given congruent angles. But as you saw, it led pretty quickly to proving congruent segments. So this proof here is an example of this last line of the chart that I gave you, where we're going to see both theorems. Let's take a look at where they are. All right, you can see that here we go in step 5, we're using that ED must be the perpendicular bisector of AB. That's that theorem 24. And then right after it is theorem 25. So we do use both theorems. Okay, we'll have some more practice with these in class. Take your time, make some note cards, and rewatch this video if you need to.